Today, lesson 27B, we continue with our topic of volume. Today, volume of cylinders. And remember, whenever we find the volume of anything, we're trying to figure out how much space is enclosed inside whatever shape it is that we are talking about. Okay, so let's continue on. So we've been dealing a lot with three-dimensional figures lately. Well, we're going to put a name to some of those three-dimensional figures. In fact, a name to all of the three-dimensional figures we've talked about so far, and they are called polyhedrons. And a polyhedron is a closed figure that's bounded by polygons. And a polygon is a shape with sides. So here are some typical polyhedrons, like all of these prisms that we've talked about. You know, rectangular prisms and square prisms and triangular prisms. Those are all polyhedrons. And we will eventually get to pyramids. Pyramids are also polyhedrons because they are closed by triangles and squares in this case, because that is a square pyramid. We could also have a triangular pyramid. That one is closed by triangles. And remember, any shape with sides is considered a polygon. And then we've also talked about how to find the volume of composite figures. Like, for example, this is a rectangular prism with a triangular prism on top of it. So that's still a polyhedron. But the following shapes are not polyhedrons. Can anybody tell me why this is not a polyhedron? Just that one.
Bounded by other polygons. The circle would not be considered a polygon because it has no sides.
Exactly. It's still a three-dimensional shape, but it's not considered to be a polyhedron. And much like I've kind of explained how I always thought of a rectangle compared to a parallelogram, where you take and you squish it sideways, or if you take a square and squish it sideways, that's a rhombus. Well, if you take a cylinder and squish it sideways, it's still a cylinder. It's just considered something that's called oblique, or an oblique cylinder. It doesn't change the volume of it. It'll still have the same amount. If you're putting water in there, it'll still contain the same amount of water. And then we have cones. Obviously, it's not a polyhedron because of the circle. That's what messes it up. And then we will eventually get to spheres as well. But spheres are not considered to be polyhedrons either for the same exact reasoning. All right, so we're going to go backwards about 3 lessons where we talked about cross-sections. It's that day that we did an iPad activity so you could make a little more clear on the cross-section or slices that you were seeing. So a prism has the same cross-section parallel to the base all along its length. So that triangular prism, if you slice it, the cross-section that's created, if you slice it parallel to the base, you have exactly the same size figure. Same thing in that rectangular prism. Well, I brought up, for future knowledge, this Cavalieri's principle. And it's a principle that states that 2 prisms will have equal volumes if their bases have equal area and their altitudes or heights are equal to each other. And I showed you a picture of quarters, and then I kind of pushed the quarters sideways to make it kind of look oblique when I brought up this principle. Well, it is this idea that leads us from the formula that we use for prisms, and we realize that it will also work for cylinders. So you can think of volume this way. The volume of a three-dimensional shape with parallel bases is equal to the area of the cross-section times the altitude, as long as the cross-section is parallel to the base. And once again, this sort of leads us to the fact that the same formula will work for prisms and cylinders. Because if you slice a cylinder parallel to its base, you have a circle that's the same size as the base. So that will work also for prisms and cylinders. And so if we put all of these ideas together, here is what we have. The volume of any shape with parallel bases is the area of the base times the altitude. And I realize finding the area of that base is different, but the idea of what you're doing is the same. Okay? All right? Everybody try. the volume of that cylinder. Now I'm going to see if you can come up with this on your own. I'm going to continue with that idea of leaving things in terms of pi until the very end. So if the area or the volume of that is the area of the base times the altitude, let's get some things out of the way here. What's the altitude of that cylinder? It's 10. It's 10 inches tall. Now, what shape is the base? It's a circle. In order to find the circle, what piece of information do you need? The radius. What's the radius? It's 5. So we have to find the area of the circle and multiply that by the altitude. So let's see if you can get that to the point where you have it in terms of pi. So to find the volume of this, we need to find the area of that circle because the circle is the base, or that's the slice of the cross-section if we wanted to think of it that way. And to find the area of a circle, it's pi times the radius squared, and we know that the altitude is 10. So 5 squared is 25, so now we have 25 pi, and 25 pi times 10 is 250 pi, and once again, my advice, leave it in terms of pi until the very end. Because so far, you have not done anything even remotely difficult in terms of mathematics, right? If you go ahead and multiply earlier by 3.14, then you're sometimes going to have to deal with a decimal more than once. I'm trying to put that off until the very last step. So in terms of pi, the volume is 250 pi, of course, cubic inches. I typically, remember, don't make a big deal out of the units in terms of pi. But if you're now asked to find the decimal value, now will be the only time that you would have to multiply by a decimal. So 250 times the decimal value of pi that we typically use, which is 3.14, is approximately 785 cubic inches. So remember, in terms of pi, let's leave things in terms of pi until the very end, regardless of whether I ask you to leave it in terms of pi or not. It's going to save you time. Okay? All right. Everybody find the volume for number 2, please. Let's do it in terms of pi first, then the decimal value. In number 2, we're finding the volume of the cylinder with an altitude of 22 and a diameter of 14. But I don't need the diameter to find the area of a circle, because we do need to find the area of the circle and multiply by the altitude. I need the radius. Well, if the diameter is 14, of course, the radius is 7. So here's what we have. Pi times 7 squared times 22. 7 squared is 49. 49 times 22 is 1,078. So in terms of pi, our volume is 1,078 pi. Now we can officially multiply by 3.14 to find the decimal value, and that would be 3,384.92 cubic feet, and that is what pretty much everybody got. Okay? Now before we do another problem, we've been talking a lot about different terms in geometry. Perimeter and circumference, and this is there's an area in your notes where you're supposed to be filling in some blank areas. When we're finding the perimeter or circumference, we're finding the distance around a shape. And an example in real life where that may come into play is how much fencing fits around somebody's yard. If the yard is rectangular in shape or has sides, that would be considered a perimeter. If it's circular in shape, that would be considered circumference. But both are dealing around the distance around some sort of shape. If we're talking about area or surface area, which really those two things are referring to the same idea, we're trying to find the amount of space that covers a region. If any of you have ever had new carpet put in your house or where you live, that's a perfect example of area. And most times that would be area of irregular or composite shapes. How much carpet fits on that floor? That's an example of area. How much paint will it take to cover an entire inside of a house? That would be an example of surface area. And then we have volume, which we've been talking about the last couple of days. That's referring to the amount of space enclosed within a region. How much Pepsi will fit inside of a Pepsi can? How much water will fit inside of a water bottle? How much water will fit inside of a swimming pool? Those are all examples of volume. And so before I have you try the next problem, some things that I've alluded to. How much dirt will fit inside that rectangular prism? That's an example of volume. Of course, we would just need to find the volume of it to figure that out. How much water will fit inside of that water trough right there, that trapezoidal prism-shaped water trough? That's an example of volume. And so the next question is, how much liquid will fit inside this cylindrical tank? Figure that out, please. Number 3, how much liquid will fit inside this cylindrical tank? It's a tank in the shape of a cylinder. We need the radius. The radius, of course, is 4. And so we have pi times 4 squared times the altitude of 9. That is 144 pi in terms of pi. But as a decimal, we will now multiply 144 times 3.14, and that is 452.16 cubic units. All right. So let's now go to the other thing that we've been working on with different shapes. What if you have a cylinder with a smaller cylinder cut out of the middle of it to create a cylindrical tube? Well, all of the ideas that we've been talking about all still apply. We would want to find the volume of the outside cylinder and take away from that the volume of the inside cylinder. And if you didn't think that leaving things in terms of pi was important before, you better change that thought process, because it is in this kind of problem where it's really going to save you a ton of time. Otherwise, you're going to be dealing with the decimals several times. So let's do what I just said. The outer cylinder, take away the part that's cut out of the middle to create that tube, the inner cylinder. So the outer cylinder has a diameter of 14. Of course, the radius is 7. So we have pi times 7 squared times the 30, which happens to be the altitude of that. And if we figured that out in terms of pi, 7 squared is 49. 49 times 30 is 1,470. So the outer cylinder has a volume in terms of pi of 1,470 pi. And so now we need to find the volume of the inner cylinder, which has a diameter of 12. But we need the radius, and of course the radius is 6. So we have pi times 6 squared times the same altitude, of course. And so that's 36 pi times 30, so that's 1,080 pi. And so you have to admit, mathematically, we haven't done anything difficult in terms of multiplying yet. So this was a cylinder with a volume of 1,470 pi, and cut out of it is a smaller cylinder with a volume of 1,080 pi in terms of pi. So that's exactly what we're going to do. We're going to take the outer one and take away the part that was cut out. And so we've talked about this idea of combining like terms with pi before. 1,470 pi, subtract from that 1,080 pi, leaves us with 390 pi, because 1,470 minus 1,080 is 390. Now that's in terms of pi. So of course, to deal with that as a decimal, you'll now multiply 390 times 3.14, and that is 1,224.6 cubic units. Okay, so let's take a look at number 5, and you're going to do that one by yourself. This is find the volume of the metal needed to make the cylindrical tube after the inner cylindrical tube has been cut out, or it should be after the inner cylinder has been cut out. Looks like a big roll of toilet paper, but it's not. Go ahead and figure that out. All right, I want to bring up something that I saw one person do, And the reason why I am bringing it up is because it alludes back to the very beginning of this lesson where I talked about the fact that we could think of this as the area of the cross-section that's parallel to the base times the altitude. Here's what Lucas did. He did this. He said, all right, well, the area of the outside circle in terms of pi is 1600 pi, in other words, 40 squared pi. And then he found the area of the inner circle, which is 25 squared pi or 625 pi. And then he multiplied that by 12. That's that whole idea of what I talked about at the very beginning. He found the area of this outside circle, and then now he's going to multiply that by the altitude of the whole thing. That's exactly why I brought that up at the very beginning. And I'm not saying that that's the reason why he did it that way. He may have already figured that out on his own, which is great, but that is really the same idea of something that you could do. The area of the slice, if you cut it parallel to the base, times whatever the altitude is. And that might make the numbers a little more manageable if you dealt with it that way. So you would combine like terms in here, which Lucas is what? What were you left with? Right, 975 pi. And then now you'd have to multiply that by 12, which would give you what you would end up with anyway. But I just wanted to bring that to your attention because I thought it was good that he did it that way. All right, so I'm going to do this the way that I talked about in the first one. The volume of the outer cylinder in terms of pi is 19,200 pi. The volume of the inner cylinder in terms of pi is 7,500 pi. And now if we take out the 7,500 pi from the 19,200 pi, we're left with 11,700 pi, which is what Lucas ended up with. And now we need to convert that to a decimal or multiply that out to get a decimal value. And that would be 36,738 cubic centimeters. Okay? All right, last problem for today. Number 6. And I would like you to work on that one with your shoulder partner. Talk about how you're going to attack it, what you're going to do, and then let's get that completed. In number 6, I see this as a square prism with a cylinder cut out of the middle of it, and the cylinder has a diameter of 5. And so the outer prism is, of course, the area of the base, which is 100 times 10. And so the volume of the prism is 1,000 cubic centimeters. And we're going to take away from that the volume of the cylinder. Well, the volume of the cylinder comes from pi times the radius squared, which is 2.5 squared, times the altitude, which is 10. And that would be 62.5 pi. And, of course, we can't combine pi's because the prism doesn't have pi involved. So you'll have to figure out what 62.5 times 3.14 is, and that is 196.25. And now 1,000 take away 196.25 is 803.75 cubic centimeters. Questions?